G'day and welcome back to the human Ransource machine, where we are continuing to program our way to success. I'm trying to do all of the puzzles. I'm not trying to optimize all of the puzzles. That's the kind of thing that I think is best done off episode. There's enough time in these spent with me trying to figure things out. So, there we go. Remember last time when I told you you didn't need to divide? Well, now you get to. Okay. For each of these, how many times does it do this? Okay. Yeah, that's actually pretty straightforward. So we take our modulo. Right? Cancel. Okay. And we copy this code. And rather than getting the modulo, we're trying to get a counter. So, paste. We also want, here we want a count. So in our initialization, right here, we also want to copy from 0 and copy to count. Okay, so then whenever we reach the end, like we do this bit, we want to bump count. Then we outbox. When we outbox, we copy from. We actually bump -1 count. And do this. And I think that should do it. We get a 5, we get a 2. We get 5, 1. Oh, I didn't think that entirely through, because once we bump, we're going to copy from first again. Yeah, okay, let's do this and see. I think I've screwed that up though, because I think I'm copying this each time, which is not going to give us the sustainable number that we're after. Yeah, no, that doesn't work. Okay. Copy from first. Copy to here. Copy to here. And then copy from oops. Wait, and then copy to, bump, copy from. That's the key. This is what I want. I never noticed that the room sways before. We get a 2. No. Why? Wait. Oh, it's because I'm copying from first again. No. I want to copy from here. There we go. Yes, that's exactly it. I even got the 0? Yes! Oh, one too many commands. and slightly too fast. Not too fast, slightly too slow on average. But that's fine. Alright, so technically this is the 27th year. But I'm going to do the 3 sort because that seems more sensible right now. Okay, yes, we rank all our employees here. From worst performing all the way up to best performing. What? Where do you rank? Let's give it some thought while we complete this assignment. For each 3 things in the outbox, send them in the inbox, send them in the outbox in order from smallest to largest. So they've helpfully initialized it. We get this. Okay. So we also will need scratch. So let's just call this X. What we're doing then is we want to copy from 0 sub 1, and if it's negative, then we move on to the next bit. So if 0 is greater than 1, then we actually need to copy to X. Then we need to copy from 1 and copy to 0. And then we need to copy from X and copy to 1. Right? So this basically bubbles. It takes our 2 numbers and it swaps the 2 in place. So this is a swap approach. We then compare these 2 numbers and we do the same thing. So we copy from, in fact we're currently holding the larger of the 2 numbers, right? So we then can go and sub this, and if it's negative, alright, and so this should be preceded by this bit. If negative, that actually no, because of that negative we want to copy from 1, and then we can sub 2. Yeah, that's good, because this is only relevant in that situation. So now we're copying from, we're subbing 1. If that is negative, we want to do something, and that is swap the 2 numbers again. So we go again. Oh wait, if it's negative, copy from 0. Before we do any of that, because we want to move 0 to 1 and 1 to 0. Yes, good. If it's negative, we want to copy from 1, because 1 is clearly bigger, because that was what we were comparing. But we then want to copy it to X. We want to copy from well, then copy from 2, copy to 1, copy from X, copy to 1. That. Copy to 2. Right? That gives us everything. And it's from smallest to largest. The final step is copy from there, outbox, copy from here, outbox, copy from here, outbox. And I'm pretty sure I have missed a very vital but important thing right now, which is what happens. So right now we've got, if this is the biggest number, it'll go to there. What if this is the smallest number? And that is the thing, right? What we actually should do is, we could set a counter, because we should go through this twice. Because if you go through it twice, then it's slower, but it will fix that problem. I mean, if we just go and do this now. Alright, we got 7, we got 5, we got 3. So we're comparing 7 and 5, and 5 and 3. Right. I don't know why my first comparison failed. 952. Yeah, so this is the test case that fails actually. But it also failed previously. 954. I think right now I've just kind of got it not swapping correctly. Because if these are just in bad order. 1. Yeah, okay, so 0 is the bigger number. But then why does this bit work? Right, I mean, I've screwed up this. I just don't understand how. Right, we're subtracting this number from this one. And so if this is the bigger number, then it won't be negative. That's my problem. Okay, sure. And if it is the biggest number, then we need to grab... If 1 is the bigger number, in which case that thing is negative, then... Yeah, okay. I need to sort out the next bit, but still. Okay, so that goes here. There, 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 there. Okay. Okay. So, if it is... So this is also just not triggering at the right point. If it's negative, we need to copy them. Sorry, if it's not negative, we need to copy them. And it's just because I then screwed this bit up, which is if it is negative, we don't want to copy. We don't want to do anything. We just want to go straight to the end. There we go. There's 9. Yeah, okay, cool. We get to the end, and then actually what we want to do, basically, is we just want to do this initial check again. Right? We want to do this bit again. And I kind of wish I just had a counter to do this again. So I know that what we need to do is we need to basically compare these two positions again. Right? So what we want to do is we want to copy from 0 and we want to sub 1, and if it's negative, everything is fine. Otherwise, we copy from 0, we copy to x, we copy from 1, we copy to 0, and then we copy from x, and we copy to 1. Otherwise, we just go straight to the end. There we go. And this is where I really should, like, have code comments. Because that would be so good right now. And this is a really crappy bubble sort, specific to 3 items. Yep, okay. There we go. There we go. 3 sort. Way too many commands, and it's really slow. And I do not want to touch it again right now. I'd be really interested in working out how to do these faster, but that's for another time. For another time. Let's see what's on this break. Where's the city? There's a lot of smoke here. And a very large rising either moon or explosion. I'm guessing it's a moon? But there was that robot army. But I could have sworn there was a city out there. What happened to the city? Oh, I see. It's actually a giant eye. Well, that kind of explains that then. And now there are lots of smaller eyes. That's fine. Yeah, nothing wrong with eyes peeking into an office building, I guess. Alright, storage floor. We made it to milestone 4. Big changes are coming, but I see you already know that. It's because we've changed our hair again. Yes, you can now access slots on the floor indirectly. What does that mean? You'll see. It's gonna change everything. It will. Imagine each thing in the inbox is an address, and each address refers to tile 0 to 9 on the floor. Your task for each address in the inbox is to pick the letter at that address and outbox it. So that means, now, we go... yeah. So we inbox, we copy from, kind of. We don't actually want to get 0 though. How do we do this then? Oh, I know. I think. How? No. I don't actually know how you address it properly. Because what we can do is we can copy to here, right? And then we can copy from the thing in 12. And then we outbox it. And then we go back to the start. I think that's what we need to do. And that's why it had copy to and from 12. We get 0, and yes, see, here's our pointers. Okay. This allows us to do even more confusing and complicated things. Hooray! Pointing at things. And it's the first one in a while where I've gotten the 2 lights done. Special covert assignment. Management is requesting strings from the floor. Let's process the strings and not read or discuss what they say. It would be impolite to read messages intended for someone else. And forbidden. Get... Each thing in the inbox is an address on the tile on the floor. Outbox the requested item from the floor and all following items until you reach a 0. Repeat. Okay, so what we do is we inbox, we copy to 24, which is, which is our point. Right? And then what we do is we copy from point, outbox, bump, point. Actually what we do is we check if 0. If 0, we go back to the start. Otherwise, copy from point. And if 0, we go back to the start. Otherwise, we outbox, we bump point, and then we go back to copy from point. Ah. Yeah, that should be it. So let's see. 4. T. Yeah, TH, obviously, because, yeah. Yep. The tar 10. The target. And 21. X 17. The target XX is awake. XXX. T and 13. Take 4. TH 17 is gonna be take this XXX. The target XX is awake, take this XXX. Because I'm moving faster than the animation of the algorithm is. There we go! Yeah. String reverse. Ale. Jadot era wo. Aha. Aha, okay, now seriously. Okay, for each 0 terminated string in the inbox, reverse it and put the result in the outbox. Repeat. So, how do we do this? So what we want to do is we want to copy to that. Yes. Inbox, copy to where it's pointing to. Bump. That. Yep. Yep. I'm following. So actually it's inbox if 0 move to our outboxing, which we'll deal with later. But inbox, copy to, yes. Okay, bump. And then we want to go back to the inbox. And basically we keep going. And once we get a 0, we go, okay, we start our outboxing process. Our outboxing process is copy from 0, outbox, bump -1, 0. If negative, go back to the start. By really go back to the start, I actually mean this. If it's not negative, go back to here. Because we even want 0. So let's see. You can't copy 2 with an empty tile on the floor. Try writing something to that tile first. Oh, wait, I see the problem here. And this is why I should label things. Because otherwise, you get that. One who... Oh! Interesting. Okay. Stop. We want to bump -1 here. On 14. Oh wait, no. I think I see the problem. But actually I don't. I still think we need this. Because we didn't reach that part. Dog. Yeah, that's right. Oh right, no, of course, because if it's negative we need to go right to the start. Also, what we then want to do, just before... Okay, what I'm actually going to do, as our very first thing, is copy from this, sorry, copy to here. And then if everything else actually refers to 13, then we can reinitialize it. Because I'm kind of screwed up, because it always ends up not 0. Ah, whoop. There we go. I mean, yeah, it's a kind of lazy way of doing it, but that worked. And we got the speed challenge, but we didn't get the size challenge because we got extra bumps than we really want. We built it such that we didn't need to rely on that. It would fix that problem. Okay. Inventory report, and then where's Carol, and we will be finished for today. So we can try and finish everything up next time. Inventory check. Accounting verification. Surprise audit. These are a few of my favorite things. So let's get started. For each thing in the inbox, send to the outbox the total number of matching items on the floor. So we got to do a search. An account, basically. And that is going to be interesting, because this is actually our terminator. So what we're going to do first is copy from, and I'm actually going to call this term. Right? So copying from our terminator, and we're putting that here, right, as our count. Actually, this is X, because count is the count of things we have found. Oh, also we're going to copy 0 to count, because we found none. Alright, so then what we do is we go for X, we inbox because we want to compare. So we're also going, and we don't have an equals, which is one of the interesting limitations we have here. We can't actually equal anything. We can only subtract and check if it's 0, because that's when it equals. So we want to inbox. We then want to save the inbox to search. And then what we do is we go copy from X, right? And we check if it's 0, we want to reinitialize. Well, actually, we want to outbox then reinitialize. So we're going to just go here, right? We want to copy from our count, outbox, and then reinitialize, which will involve jumping right back to the top. But if it isn't 0, what we want to do now is we want to subtract search. If that is 0, we want to bump count. Then we also want to bump, regardless of if it's 0 or not, we also want to bump X. And after that, we want to go back to our copy from where X is pointing. And I think that should be it. So here's our initialization, putting 0 everywhere. We get our B, and we grab B. We subtract B, which gives us 0. Because it's 0, we do that. And if it isn't 0, we do this. Yeah. What we actually can do, though, is we can bump X, and then, right, because that's always going to be a thing. And if it isn't 0, we count. If it is 0, we go back to the start. Otherwise, we go down. I think this is the first time I've managed to... Whoop. I think this is the first time I've managed to actually do that, though. So let's see. Initialization. Go to X. See, this is effectively numbers, right? So this is why we can do that. No. Because if it's 0, we need to go back. I was so close. Because if it's 0, we want to bump count. Right? What if we then, at the end of all this, we bump -1? There. This is kind of also dodgy, but... Oh, whoops. We don't want to bump 0. We want to bump -1 count. In fact, that allows us to do this. Yes, yes. There you go. Nope. Yep, I think this is working. But let's see, because the first test is really when we get a C. Hang on. We got a C. Why didn't you do that? So if it is 0, we're meant to go back to here. And if it isn't 0, let's try this again. Hey. Bump X. Hey! Hey, wait! Of course, it's never 0. So we're not actually checking. Right? Because we do our sub. Right? And we bump X. After that. So what we kind of want to do here is we want to bump X up here and copy from it. Which means we want to do something which seems really strange. Which is we want to bump X and then immediately reduce it by 1. And that also allows us to get rid of this. No, it doesn't allow us to get rid of that. That bump is fine. But it means we want to get rid of this bump and replace it with a copy from. And this will all make a little bit more sense in a moment. So we got our negative numbers. X. Nope. There are 3 X's? Yes, yes, it works, it works. It seems so strange, but it works. Mostly because we're initializing things to -1, just so on the first loop we don't have to do as many jumps. And this is really slow because this is us having to search for a string, character by character. Yeah! Yeah! Double optimization on inventory report. Ah! It's so much easier now I can point at things. As strange as that may sound. Where's Carol? And that's the city. See, that was why that was bizarre.
Hey, where's Carol?
Oh, there's Carol.
Oh my god. This coffee is amazing.
That's terrible.
Back to work, ladies.
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
Oh, I'm glad. That's very reassuring to hear. This has been today's episode of Human Ransource Machine. I hope you've had fun watching. I've definitely had fun playing, and I want to play more.